What kind of questions do you have for me on page 25, 26? Anything I can work out? Number 10? Got it. That's a good one to ask about. That's a great one to ask about. Thank you. It's the reason why this one looks a little complex is like, dude, you have x and y. Agree? So if I multiply here and here, I'm going to get 12x squared. Do you feel comfortable with that so far? And then anytime I multiply letters together, I'm always going to put them back in alphabetical order. Does that make sense? So if I was multiplying A times C times B, I would make sure it's ABC. Does that make sense? Okay, so I'm going to multiply those together. So that's going to give me negative 18xy. Is that okay? And then I'm going to multiply these. That's going to give me negative 10xy. And I multiply here. That's going to give me plus 15y squared. Do you feel comfortable with the work I just did? There are some like terms. And again, the reason I say put them back in alphabetical order is those are going to show you some like terms. So I'm going to get negative 28xy plus 15y squared. That help you out, Trev? Cool. What else do you see, friends? Yes, sir. Yeah, happy to. 14. Find the area. Okay, that's a good one. So you have this triangle. Looks like this. So we want to find the area. So we have to kind of revert back and remember area of a triangle is 1/2 base times height. Okay. So area is equal to 1/2 base 4x minus 2 height x plus 2. Okay. So before I start multiplying things together, I'm going to take care of this. I don't have to multiply through 1. So does it make sense to multiply through the first or the second if I'm taking half of stuff? What do you think? The first. Very good. So I'm going to go here and here. So that's going to give me half of 4x is 2x. Half of 2 is 1. And then I have this equation. Does that make sense how I just got rid of the fraction? Then we're going to multiply together. 2x times x is 2x squared. 2x times 2 is 4x. Negative 1x minus 2. These are like terms. So that's what the area of the triangle would be represented as polynomials. Any others I can help you with, my friends? Yeah.
So for 14, could you just also multiply the two trinomials and
then perfect. Yeah. Yeah, so that's a great question. If you multiply these together like we were doing here, if we multiply this, so I got 8x squared plus 6x minus 4, and then took half of that, you're going to get the exact same answer. I like that. 4x squared, it comes up, 4x times that is 4x squared, so that should be 4x squared plus 6x plus minus 4, and then you get half of that. Yeah, that's totally going to work. So multiplication has that fun property. Doesn't matter what order you do it in. I like it. What else can I help you with, friends? Good? Yes? 15? Right. So number 15, this is where we start changing gears back. We have to realize I can drop both sets of parentheses as they sit, so I'll just rewrite it without the parentheses. Is that okay? And then I'm just going to combine like terms. So I have 3x to the third plus 5x squared plus x minus 3. Okay, so that was just adding the polynomials, not multiplying them. Okay? We good? We feel comfortable? You're happy? We're at school. But I'm happy to see you when you're at school. I love you guys. I love you guys. You guys are awesome. I tell you what, if you're in my 5th period class, forget about it.
What do you mean by
And in my 7th period class, forget about it, man. You guys are out of control.
I'm gonna stab these kids with my 7th period trying to get by.
All right. I'm just joshing. 7th period is my favorite. Oh, wait, 5th period is my favorite. I mean, 7th is also. 7th is first favorite. 5th is first favorite. 3rd is first favorite. So which one's your favorite? You're all special.
That's not how that works.
Stirrups game. I can play. All right. So my friends, I'm gonna go here. I'm gonna open up this one. Come on, open up. We are skipping 4 because I think 4 is busy work. So go to, come on. There we go. All right. Would you turn to page 29 of your notes, please? 29. Okay. There we go. Give me a second. Okay, so yeah. Isn't this like the 4th day in a row you went and get your book? Okay, 3rd day. Hurry up. Run fast. It's not the track team. I said run fast. All right. So before I get into this is what we're going to start doing. Now, friends, you got to trust me. I'm going to get you through this stuff. Okay? But you have to be trying. Okay? If you try the homework and you don't get it right, then we'll make the correction the following day. Coming in and trying to write down questions as fast as you can is not going to be real helpful. But let's just start out with this. I know this is not in your notes, but I just want us to think about it. Let's talk through this problem. I multiply this times this, I get 2x squared. Agree?
Yeah.
If I multiply this, I get minus 3x. If I multiply this, I'm going to get plus 10x. And if I multiply this, I'm going to get negative 15. Agree? These right here are like terms. Okay. So, my friends, if I can go from 2 binomials being multiplied together to getting us this quadratic trinomial, there's got to be a way to go from this back to this, undoing it. Agree? That's what we're going to do. Now, I'm going to show you a method. It's going to be relatively the same each and every time I show it. Okay? But I want you to hear the vocabulary I say each and every time. I'm going to try and stay consistent on it. Now, I kid you not, something we're going to look at is called factoring. Factoring means I'm undoing this, taking it back to this. Hello.
Hi.
He's here now. Cool, thanks. Okay, so factoring is undoing, making it back into, parts. There's all kinds of different methods of doing it. There's one method they call the dream method. Sounds good. There's one that's called the diamond method. It's fine. There's the square method. That's fine. And I kid you not, there is a method that I'm going to show you called the Cherry Creek method. It was not developed at Cherry Creek High School. It came out of Cherry Creek, New Jersey. Yeah, so we're following something on Jersey. But Cherry Creek loves the fact this is called the Cherry Creek method because, dude, we're Cherry Creek. You know, if it had come out of like Grandview, Texas, and they're like, dude, this Grandview method, we would have thrown it away. We wouldn't have used it. Right? Eagle Crest method, forget it. We ain't using it. Arapaho, not going to look at it. Hey, look at this. This is the Cherry Creek method. We don't stake claim to it. We don't own it. But we're going to be stepping into this, and I'm going to be going gradual. So please, my friends, you have to promise me, if you miss class, please, you got to watch the video. You got to try the homework. You can't come in going, so what I miss? Did you watch videos? Nope. YouTube didn't work. Really? Didn't work? Okay? So please, you have to make sure you're going to watch the methods. All right. So I am on page 29. So the first one we're going to come across is we're going to be factoring something called, wait a minute. I'm on the wrong page. Y'all never told me that. All right, I got to go back. Or I got to go to here. Sorry. Open that. So, do I have your word? If you miss, you're going to watch, please. You're not going to watch while you're in class when I'm trying to teach the next lesson. You're going to watch while you're at home, not feeling well. Okay? No one knows where you're watching. Okay. So, the first screen we get to is this. Okay? I realize yours is in gray tones. Sorry, we didn't do color paper for you. So I'm going to multiply these problems together, and then I'm going to start skipping because something takes place. Now, take a look at all the different colors. There's a bunch of binomials in each. 2x minus 1, 2x plus 1. 3x plus 5, 3x minus 5. Y minus 2, y plus 2. A minus 4, a plus 4. 4x minus 7, 4x plus 7. 2x plus 6, 2x minus 6. What do you notice about each of the colors and those binomials inside? What's opposite? I like what you're saying.
It's like kind of that.
Okay. Okay, let's look at the yellow one right off the bat. What can you tell me what's different between those two binomials? What's the main thing that sticks out? The signs are different. The signs are different. Everyone agree? They're the same binomial, but the sign, you have a plus and a minus. Agree? All right, so if I were to multiply this out, this would be 2x squared minus, or let's see, plus 2x. Yeah. Stirp can't even teach right. That's minus 2x minus 1. These are the same. So that's what the yellow one is. The red, 9x squared. I got that right this time. Minus 15x plus 15x minus 25. Those cancel. This one, y squared plus 2y minus 2y minus 4. Those cancel. We're starting to see a trend that just happened with those top three. Do they all three have a subtraction sign? Okay. Do they all three just go down to two terms? Okay. We're on page 29. Okay. Do all of them have like the middle stuff gone? Okay. So same binomials, except one of them has a plus sign, one of them has a minus sign. Agree? So I'm trying to baby step into this. I want you to see the pattern. Okay, so now let's think what we could do with this. Is my head in anyone's way? I'll duck down. All right, so let's see. 2x times 2x is 4x squared. Negative 1 and positive 1 is 1. 3x times 3x is 9x squared. 5 times negative 5 is negative 25. Y times y is y squared. Negative 2 times positive 2 is negative 4. A squared minus 16. What do you think? Did I follow the pattern? A times A squared. 4 times 4, 16, negative. This next one, 4x times 4x, 16x squared. 7 times 7, bless you, 49, separated by a subtraction sign. 2z times 2z is 4z squared. 6 times 6, negative 36. Does it appear there's a pattern that's taken place? Can you see over my head? Can you see over my head? Okay. Claire, I'd ask you, but I'm pretty sure you can see past me. Thanks, Ellen. Okay. So there's a pattern. So now, being that there's a pattern, take a look. I should be able to go back to this. From the original answer, I should be able to go back to it. Okay, do you feel comfortable with that so far? All right. What's the next? Let me see. What's the next? Oh, okay. So, what do you notice? We just talked about it. So this is called the difference of squares pattern. So A and B are whatever. They can be letters. They can be numbers. A and A would be the same. B and B would be the same. I would have one being positive, one being negative. This results in this type of problem being done. That's all it is. So it's called the difference of squares pattern. Okay, so let's see if we can figure this out. Story time? Not really. All right. So x squared minus 9. Agree? Do you have that one? Is that there? Is that it? Cool. Talk to me. What's number 2? 4x squared minus 1. That's it. What's the third one? Close. Did you say minus 4? Oh, I'm sorry. Minus 4. What's the fourth one? Be careful. 10 times 10. 10 times 10. You gotta start wearing your helmet at practice, okay? A times A is A squared, yes? 8 times 8? 64. I know you were. Friends, do you see that there's kind of a pattern? So the two binomials are the same letters and numbers. The only difference is one of them's positive, one of them's negative. If you see that, you can quickly start going through them at a faster rate. Okay. Is that it? Feel good? Everyone happy? Oh, is there? Okay. Maybe at the bottom of the page. Oh, there we are. Those two? All right. Help me out. What's this, number 5? Oh, very good. 9x to the 4th. Because we add the exponents. And then? Close. Minus 1. And then this one, we're trying to trick you. Hey, how many of these do I have because of this? 2? Okay. Uh-oh, friends. Is this going to be the shortcut method, or is it different? Are these the exact same? Is one positive and one negative, or are they both the same sign? Oh, bug snot. Let's see. X times x is x squared. X times negative 5 is negative 5x. Negative 5x. Positive 25. Notice these do not cancel. Agree? Just has that. So notice, why did it not fall out? those signs were the same. They did not change. So, you got to make sure. Two binomials, everything about them is the same except for one's positive, one's negative. That's all it is. Okay? Wow. Huh. So, we're out of here like at 11. So, I wanted to give you some stuff to practice. I'm gonna saturate you with work. Good? All right. So, I want you to work on page 27, 28. 28's blank. I want you to do the odds. Is that a gift? Why is that a gift if I give you that? Yeah, you can go find those odd answers right there on Schoology. And then what I would like you to do is page 31, 32. Let's have you do 1, 4, 7, 10, 13, and then 16 through 18. So that's not all. This is just like the left column and the back page. Now, I'm giving you the rest of the period to work on it. I'm expecting you to work on it. Around help.